A good day to everyone. I am Mariselvam, yes, from India. Today I'm going to give a presentation about my PhD topic. Actually, my PhD is is divided into two sections. Where first part of the thesis is about the computational work and which follows the experimental validation. So for the today's presentation, I'm going to give the talk about the computational part of my thesis, which is the machine learning based prediction for micro pyrolysis batch production. So to start with the presentation, I'll give you a brief intro about the background and the problem statement for the research. So as we see in India, the agricultural productivity contributes around 25% of the country's gross domestic product. However, this productivity is dependent on various factors like seasons, quality of soil and land. And if we see this image shows the comparative production of crops in million tons over the decade, and the crops like sugarcane and oil seeds are being increased with years to satisfy the growth demands of human population and the day-to-day activities. So as we see the growing in production of crops, we also have to give consideration about the management of crop residues. On an average, India generates around 500 million tons of crop residues per year, and this is the data showing the distribution of crop production and the residues generated and the residues being burned. The burning of crop residues in the field is one of the crop residue management, which is the one of the easier practice being practiced by farmers. However, there is also some associated disadvantages. And this is the image showing the advantages and disadvantages. Even though this method is one of the cheap and less manpower, and it's one of the quick and easy method, there is a loss of soil nutrients and carbon, and obviously because of burning there is an increased GHG emissions, which in turn causes a negative impact on the soil microbes and soil structure. And this is the image released by NASA, where we could see the sites of crop residue burning over the few Indian states, which causes the harmfulness to the human environment. So we have to so in other side, if we see the Indian energy mix scenario, out of the energy powers, the renewable energy is contributes around 16.1% of the total energy utilization. Out of the renewable energy, the conversion of waste to power is very minimal. Even though India is one of the third largest energy consumer in the world, we have to give more focus on the waste to power utilization. So these are the current existing strategic solutions. However, each method is associated with one way or another pros and cons. So suppose if we take the livestock, if we use the biomass as a livestock fodder, certain biomass like rice straw and rice husk, owing to the high silica content and poor digestibility, it causes harmful to the animals. And if we use this biomass residues for composting, it is one of the time taking process. So in order to combat the nutrient depletion and the soil degradation and also the environmental degradation, we have to see the transition to the eco-friendly technologies, where these agricultural residues can be converted into biochar through the process called pyrolysis. This biochar we can use as a soil amendment or carbon sequestration and biofuel. So yeah, and this is the definition of biochar. As we all know, International Biochar Initiative has defined the biochar as solid material obtained from the thermochemical conversion of biomass in an oxygenated environment. Yeah, how this being produced, as we and I'll give you a brief intro about this. The biomass is subjected to this biochar is we can use after using as a soil amendment. It increases the crop yield, and the harvested biomass can we are again using uh, we, we are again producing in the biochar. So this will act as a cyclic loop of sustainable crop management, and it will enhances the agricultural productivity. So recently, people are moving towards the advanced pyrolysis technology because if we see the the advanced parallel technologies includes the microwave heating. As we see the difference between conductive and microwave heating. In conductive heating, the heat is transferred from the outside of the biomass to the inner core. Whereas in microwave heating, from the inner core, the heat radiates outside and it will heats the biomass particle uniformly. And this is the barriers and drivers of the both conventional and microwave process, where the microwave process is a highly energy efficient process, and the products which are being derived out of microparalysis of will be of higher quality. So we have decided to proceed with the microparalysis. So before starting our research, we have done a preliminary scientometric analysis where we have collected the different publications that has been published on the this microparalysis research, and we have processed these publications in the software called SiteSpace in order to carry out the scientometric analysis. So we have analyzed the different networks like countries, keywords, and the authors. So if we see the publication trend, the publication is increasing with after 2010, where rapid growth can be seen, and this rapid growth of publication shows this micropalace is one of the major research hotspot in the biochar technology. And on a macroscopic level, if we see the countries like people of Republic China, USA, Malaysia, Canada, these countries are at the forefront of the micropalaces technology. And this is the image showing the percentage contribution of these countries. And we have analyzed the different subject categories that have been published on this microparalysis research. And the categories like as you can see, the nodes of these categories: energy and fuels, and chemical engineering, chemistry engineering. These nodes are higher than the certain nodes like agricultural engineering and agriculture. So these from these subject category network, we could able to analyze that the micropalace research has been more focused on the energy based applications rather than the agricultural field. However, this finding is contradictory with the several literary reports who has done the scientometric analysis for the conventional biochar, where those biochar has shown more product more publications on the agricultural field. As we all know, the conventional biochar on the use of agriculture is well known. However, this micropalaces research is an emerging technology, and most of the applications has been based on energy and fuels. And we have also analyzed the post-cited documents. So from these documents, we could be able to, by analyzing these documents, which has been published so far, we are able to tell whatever the micropalaces research on energy-based applications mostly derived from the oil and syngas, whereas the biochar has been overshadowed. So this is the I'll be telling about the evolution of the micropalace research, whereas the initial research has started with the exploration of different agricultural waste in the microparalysis, and later started with the exploring the different catalysts, how these catalysts are improved with the then the research proceeded with different applications like using this micro data biochar in absorption, and several other applications. So from this analysis, we found that the we have to analyze the conditions to obtain the
Mary, we've lost you again. At least on my side, I can't hear you. Could you repeat, please, the last couple of sentences?
Having higher energy
Hello, Mary?
potential. So have
Hello, Mary. We can't
conducted
hear you properly at the moment.
machine learning.
Yeah, Mary, we cannot hear you at the moment. Can you stop sharing your screen so we can at least hear you?
Hello.
Yeah. Hi, Mary. I've stopped your screen sharing because it was taking too much bandwidth, I think. Can you hear me okay? Can you hear me okay, Mary? Hello,
Hello.
can you hear me? Are you back?
Yeah, I'm back. Am I
Okay.
clear now?
Yes, you're clear now. I'm wondering whether you should not just send the presentation because it's a bit difficult to follow if I mean, it depends. It's a bit volatile, your connection. Sometimes it works and sometimes it drops. Is it possible for you to share your presentation?
Yeah, I have covered almost half of my presentation. So I hope my internet is good now. So let me give a try once. I'll complete my presentation fast.
Okay, try again. Try again.
Yeah. Is my presentation
Yeah, you
visible?
can go ahead. Yeah.
Yeah, so we have carried out a machine learning study to understand the interactive effects of micro parameters on biochar yield and energy value. So this is the methodology part where we have collected the data set comprising the different parameters of biomass composition and the microprocess conditions, and we have characterized database into different biomass type, and these data sets has been subjected to the different machine learning algorithms like extreme gradient boosting, random forest, support vector machine, and so after this we have analyzed the future importance plot and the summary plot. And this is the Pearson correlation matrix showing the relationship between the input and output parameters, where the fixed carbon and total carbons are positively correlated with the biochar yield and HHV. Micro power is negatively correlated with the yield and positively with HHV. In order to understand the in-depth effects of the Fisher characteristics and micropyrolysis, we have moved forward the machine learning methods. And as we see, the XGB model has given higher prediction performance and lower on root mean square error compared to the other machine learning methods. So this XGB we have selected, and we have analyzed the importance of different futures, and we have ranked these futures based on the influence. So as we see, the micro power is the most influencing factor affecting the partial yield and energy value. After follows the power that comes the macro absorber and the microwave time in predicting the yield, whereas in case of HHV, the reaction time and the feedstock amount and the feedstock characteristics are determining the energy value. So with this machine learning method, extreme gradient boosting, and keeping the micro power constant, we have analyzed the interactive effects of other factors through a sharp plot. So from this sharp plot, we understood that a moderate power of 400 to 600 watt with higher fixed carbon content results in higher yield of biochar. Similarly, we have also analyzed the interactive effects for the HHV, where the micro time range of about 20 minutes and moderate micro power of 400 to 500 watt results in positive sharp value, which means these conditions will result in, it results in higher HHV of biochar. So Coming to the conclusion part, out of the four models executed, the XGB model has given higher prediction performance compared to other models, and the moderate micro power of around 400 to 500 watt with a lower reaction time of less than 10 minutes and the time between 20 to 30 minutes. These conditions will favor the biochar with higher yield and energy value. Uh, uh, these machine learning models are of black box nature, and these models won't give an explicit set of rules in order to implement into a practical scenario. So we have continued with the data-driven rough set-based machine learning model, where we have used a rough set concept. The data sets, whatever we have generated, that will be approximated with the lower and upper approximation, and with the approximated data set, a set of redux will be generated, and with these redux we can frame set of rules, or in other ways we can tell us a set of conditions or framework that will give us the optimal conditions for predicting the reaction. And this is the methodology part, where the data sets is divided into conditional attributes and the decision attributes. The conditional attributes are otherwise called as the input features, which are the biomass characteristics and the process conditions, and the decision attributes includes the biochar yield and HSV. So after this, we will classify the decision attributes into different classes, and these classified database will be processed in rows to software, which is the software for doing the upset concept. And with that software we will generate a set of rules which will give us the optimal conditions for obtaining the biochar with the better yield and HHP. And this is the classification of the decision attributes into 5 different classes. And this is the violin plot showing the distribution of data that has been taken for the study. And as I already told, we will get a different set of redex for the decision attributes, and these are the redex or the set of combinational parameters which are sufficient enough to determine your yield and HSV. So we have got around 11 redex for determining yield and 12 redex for determining HSV. The parameters which are common to all these redex will be called as scores. So for predicting yield and HHP, the process conditions, the like Whitstacker mode, macro power, time, and absorber are the main cores for determining the decision attributes. And this is the table or the outcome that I have been talking so far, where we have gotten different set of rules for the different classes of biochar of a desired yield, and following these parameters we will get the desired yield of biochar. And these are the set of rules for predicting the HTTP. So in order to explain clearly, I have selected the class 3 rules for class 3, where if you want to get an yield of yield and HTTP of this range, we have to follow these rules, and by following these rules we will get the desired outcome. And in order to validate this subset model, we have generated a confusion matrix, where these matrix will be interpreted using the parameters like accuracy, precision, recall, and F1 score. So if we see the accuracy, the overall accuracy of upset-based model for predicting the biochar yield is 81.8%, whereas the overall accuracy for the upset model for predicting the HHV is 87.8%. So coming to the this upset-based approach will give you the yield and the energy value of biochar. So the rules that have been given by the upset rules has been taken for the further studies. So coming to the inference part, we have conducted the different machine learning methods like regression and classification, where the important feature that have been observed from the regression technique is similar with the core feature or the important features that has been obtained through the classification. And through the regression technique, the influence of factors on the determining the biochar yield and HFG could be identified. However, there won't be any approximate range of outputs. So in using the classification methods, we could able to get an approximate range of obtaining biochar yield and HHV. Thank you. If you have any queries, I'll be happy to answer.
Thanks, Mari. I will stop your screen share, if I can. So we are actually right about the full hour now. So we won't take too much time for questions. But there was a question from Marshall, I think, about the amount of biochar that can be produced with this technology. Do you know that so far in your work? How much biochar do you produce, and can that be scaled? You're on mute, I think.
Yeah, I got it. So I have presented the computational part, whereas we have also carried out the experimental part where I have got around 30% of the yield, where similar to the other micro studies that has been reported.
Okay, but
Around 30 to 40% yield I have got.
what is the size of you do that at a lab scale at the moment, I suspect?
We have used 2 kilowatt magnetron microwave reactor.
Okay. And so you produce in your reactor, is it, what is it, a few liters or a few gallons of char that you produce?
It is a lab scale reactor. The maximum the biomass that can be processed is around 100 to 150 gram.
Okay. Um, and there was a question from Marshall again about your contact information. Do you have um, do you have something there to show? Otherwise, I believe I can also share your email address.
Yeah.
Or maybe you can also be found on LinkedIn. Are you on LinkedIn, Mary, or are you?
Shall I share my mail ID?
Yeah, you can share your email on the chat, and then
Yeah.
I think maybe Marshall, you can try to connect with him on LinkedIn if you can find him. I'm not sure if he's there. Otherwise, I can also share.
Yeah, I have shared my mail ID.
Okay, great.
Yeah.
So yeah, it should be Marizel221, no? 2210926 at gmail.com. That's the one I have at least. But anyways, thanks, Mary, for your presentation.